All right, let's imagine for a second. You're sitting on the couch after a long day. You've got a cozy blanket, your favorite snack, and a movie on. Suddenly, you think, what if I could just teleport? Like, poof, 1 second you're in your living room, and the next you're on a beach in Hawaii, sipping a coconut drink. No plane tickets, no waiting in line at the airport, just instant travel. Sounds like something out of a sci-fi movie, right? Detect Doc. This is a guy I would call for anything, unless you just want to work on technology something. Just Detect. Here it all is, Valerie. Next first associate came Audrey. This is his name. Was a man by the name of Trim Barton. Is the first associate out of California, saving the Dawson South. But what if I told you that teleportation might not be as out of reach as we think? Okay? It's still a long shot, but hey, let's entertain the idea for a minute. Now, before you start imagining yourself popping into your best friend's house uninvited, let's break it down. Teleportation in sci-fi movies like Star Trek or The Fly looks super cool. 1 second, Captain Kirk is in space, and the next, he's on the bridge of the Enterprise. Easy, right? But if you stop and think about it for a second, it's not just about disappearing and reappearing somewhere else. It's about transporting all the information that makes you, well, you, across space in the blink of an eye. Sounds mind-boggling? Well, it kind of is. So why is this even worth exploring? Teleportation could change everything, our idea of travel, our economy, how we live, work, and interact with each other. Imagine never sitting in traffic again, because let's be real, that's the dream. But also, teleportation raises some pretty mind-blowing scientific and philosophical questions. Could it work? How would it work? And most importantly, if you could teleport, would you even want to? Stick with me, because we're about to take a wild ride into the world of quantum mechanics, sci-fi fantasies, and maybe a few big questions about what it really means to be you. Let's dive in. All right, let's get into the nitty-gritty of how teleportation could theoretically work. But before we start imagining ourselves zipping around like Doctor Strange, let's break this down in a way that's digestible and hopefully not mind-bending. We'll tackle this like a layered cake, one sweet concept at a time. Teleportation sounds like magic, right? 1 second you're in one place, the next you're, poof, somewhere else. But here's the twist. It's not quite as straightforward as it seems. When we talk about teleportation, what we're actually talking about is transferring information. It's the very essence of what makes you, you, from one place to another. In that way, you can think of this as the law of reciprocities. If somebody wants to, think of it like an incredibly advanced, super efficient Wi-Fi connection. If we could somehow send all the information about your atoms and molecules to another location, then theoretically, you could rebuild yourself there. Now, before you start worrying about losing your socks in the process, let's clarify this idea of teleportation is quantum teleportation. And it's not about sending big things like you and me across the room with the flick of a finger. Instead, it's about teleporting information at a subatomic level. We're talking about particles, quarks, electrons, all that tiny stuff that makes up everything in the universe. The fancy term for this is quantum entanglement, and it's both confusing and absolutely mind-blowing. Here's where things start to get a little weird. Albert Einstein, the Einstein, wasn't a huge fan of quantum entanglement. He called it spooky action at a distance. But let me break it down. Quantum entanglement happens when two particles become linked in such a way that their properties are connected, no matter how far apart they are. So that's what you want. There's no way a 49-year-old Hal trying to learn how to raise a... It's like these particles are best friends who finish each other's sentences, even if one is on Earth and the other is light years away in the Andromeda galaxy. Now, don't go trying to send your morning coffee through space using this concept. The particles involved in quantum teleportation are tiny, smaller than a grain of sand. But here's where it gets juicy. Scientists have actually managed to teleport information between particles. So let's say you have two entangled particles. One particle can be on your desk and the other could be in another room. Now, if you change something about the particle on your desk, the entangled particle in the other room will instantly change too, in perfect sync. It's almost like the universe is playing some kind of cosmic game of copycat with quantum particles. Particle expanders are very, very, very powerful. Prototypicals for nuclear reactors are not big. We know that in the fine arts world. But ever since I got into animation, guys, are being able to, what does this mean for teleportation? Well, if we could somehow use quantum entanglement to transfer the entire structure of a person, and I mean everything about you, your position, your atoms, your quantum state, theoretically, you could teleport from one place to another. It's like the universe has a super sophisticated printer and quantum entanglement is the ink. Cool, right? But let's step back for a second. Something in real life, we're still a long way from teleporting humans. As of now, we can only teleport quantum information, like the state of photons or particles. The first successful teleportation experiment happened in 1993 when scientists managed to teleport the quantum state of a photon over a distance of about 6 miles. Yes, you heard that right. 6 miles. But here's the problem. On the big screen, there's such an exceptional demand that every time a train goes by, that's far, but when you're thinking about teleporting, 6 miles is just a teeny tiny step in the grand scheme of things. To make this work for humans, we'd need to find a way to teleport all the information about our atoms, molecules, and subatomic particles. And this is where things get complicated. For example, a human body has something like 37 trillion cells, and each cell is made up of billions of atoms. That's a lot of information to transmit, and as we all know, our Wi-Fi is exactly known for its speed. So the simplest thing you could do would be to transmit information down to the before times and after times by constructing this triangle between the worlds and each cell. And this is where things get complicated. For example, a human body has something like 37 trillion cells, and each cell needs to meet certain minimum of standards. If teleportation were to work, we'd need to transfer an astronomical amount of data, which brings us to our next point, the data problem. Now, imagine your internet speed. You know the feeling. You're trying to stream a movie and the buffering symbol is just staring at you like an evil eye. Now, imagine trying to send every single detail about every single atom in your body to another location. That's a lot of bandwidth, my friend. You need an intergalactic internet connection with speeds that make fiber optic cables look like snail mail. Even the most advanced supercomputers today could barely handle this level of data transfer. Plus, here's another fun twist, the Heisenberg uncertainty principle. Essentially, it says that you can't know everything about a particle's position and momentum at the same time. So when you're trying to teleport something, this principle creates a huge roadblock because you'd need to know the exact state of each atom before sending it. If the data isn't perfectly precise, you might end up in a mess of scrambled information. Think of it like trying to send a 4K movie through a dial-up connection. You're not going to get the picture right. But let's not get too bogged down in the technical stuff. The point is that teleporting humans is way more complicated than sending a text or a photo. Still, scientists are working on ways to overcome these challenges, and who knows, in a few decades, we could be talking about teleportation like it's a regular Tuesday. Now, let's get into the real fun stuff. Let's talk about the philosophical and ethical implications. If we could teleport humans, actually teleport ourselves, what would that even mean? Imagine for a second that teleportation becomes as easy as using a ride-sharing app. What happens to transportation? Does the economy crash because no one needs planes or cars anymore? Will cities change because people aren't restricted by distance? What happens to the way we think about time? And think about this. Right now, we define ourselves by our locations, by where we live and where we go. And we say, I'm in New York or I'm in Paris, and that tells people something about us. But if teleportation existed, would we still need a sense of place? Could we just teleport to wherever we feel like at any moment? If we could be anywhere in the world instantly, how would that change our relationship with our surroundings? And here's a twist. Could teleportation mess with our sense of identity? Let's say you teleport, but something goes wrong. What if the transfer isn't perfect and a version of you arrives at the other side with a few quirks? Are you still you, or are you something else, a copy of yourself? And if you're a copy, what happens to the original you that stayed behind? So, as a matter of time, I'm going to more transition to that side. So we explore further with the interview by asking Elvis Bozeman. Now we're venturing into the deep end of the philosophical pool, but hey, it's all part of the fun, right? The idea of teleportation isn't just about jumping from place to place. It's about how it would change the very fabric of existence. It could reshape everything we know about travel, time, and even life itself. So after all this, where does that leave us? Could teleportation happen in our lifetime? Probably not the way it's portrayed in movies, at least not anytime soon. But the science behind it is real. Quantum entanglement is a thing, and every year researchers push the envelope just a little further, moving closer to the possibility of teleporting particles and eventually, and just maybe, humans. Will it be a smooth transition from one place to another or a total disaster? Who knows, but it's certainly fun to imagine. And in the end, the idea of teleportation invites us to question the very nature of our reality, what it means to be here and there, and whether distance even matters at all in the grand cosmic scheme of things. Just remember, if teleportation does become a reality, don't rush to buy a ticket just yet. I'm pretty sure your credit card won't handle the instantaneous teleportation fee. But hey, one can dream, right? So here we are, after diving deep into the rabbit hole of teleportation. Who knew a simple question like, what if we could teleport like in sci-fi movies, could lead us down a road full of quantum particles, philosophical dilemmas, and dreams of never having to sit in traffic again? The truth is, while teleportation might still sound like something from a futuristic Star Trek episode, the science behind it is anything but fictional. We're already experimenting with teleporting tiny bits of information, and who knows? Maybe one day we'll get to the point where you can zip across the world faster than you can say, I'll have a coffee in Paris, thanks. Oh, but here's the kicker. Even if teleportation becomes a reality, will it change us as much as we think? Will it redefine our relationship with time, space, and the very essence of who we are? Maybe teleportation will just be another cool trick we can do, like flying cars or robots doing our laundry. Or maybe it will force us to rethink our connection to the world, our bodies, and the idea of being somewhere. It might just be the kind of thing that forces us to realize distance is a lot more than just miles between us. It's the very way we experience life. And so we'll leave you with this thought. If we can one day travel the universe in the blink of an eye, will we lose a little piece of what makes us human? Or will teleportation just be another adventure in this wild, unpredictable thing we call life?